Alright, so what happens if we're in standard form? So we talked about how there being two different forms, so this would be in standard form. And remember that in standard form, getting a little bit of lag here, in standard form, the equation would look something like f of x is equal to ax squared plus bx plus c. And so we can see here that we have an A, a B, and a C. So in our case here, the A would be equal to 3, the B would be equal to 12, and the C would be equal to 9. And we actually won't use the C in this problem, but in this case here, just so that we can see that we can pull it out. Alright, so we start the question off. Our first thing is that does it open up or does it open down? So we look at number 1, our A value is equal to 3, and that's greater than 0, so I would open up. Obviously, when you look over this guy, my A is equal to negative 2, and so I would open down. I'm going to hit pause just for 1 second and see if I can get this hesitation. Never mind, it's kind of slowing down. Alright, step number 2. Let's kind of change colors here. We'll go back and forth between blue and black. So number 2, what is the vertex? Well, in this case here, we can't see transformations. We don't have it in that vertex form, so we have to calculate it. So we have a formula for the vertex. So in this case here, we're looking for our vertex, and we do our vertex. We can actually find the x portions. Remember, the vertex is an ordered pair, an x and a y. So we can find the x value. We take the negative of the b and we divide it by 2a. So in that case here, that would be negative 12 divided by 2 times 3, which we simplify to negative 2. So we come up here, that means that the x portion of vertex is negative 2. To find the y portion, we just take that and plug it back into our original function. So in this case here, sorry, I put f, but we actually have g. So our equation is g of negative 2. And so that would be 3 times negative 2 quantity squared plus 12 times negative 2 plus 9. Now I'm not going to lie to you though. I'm not actually going to do that. I'm going to go to my calculator at this point because we have this tool, and I'm going to plug my function into the calculator. So I'm going to plug in 3x squared plus 12x plus 9. Yes, plus 9. And I'm going to go ahead and hit graph and see what it looks like. Okay, so it definitely opens up. Good job. My vertex is definitely at negative 2, negative something right there. But so I can go to my table and see what that actually is. So I can go to negative 2. And just a minute, I'm almost there. And I can see that at negative 2, it would come out at negative 3. So that would be negative 3. So remember, that's the same thing as if I plug this in. So if I went to my home screen right now, if I went to my home screen and I plugged this in right here, this would be 3 open parentheses negative 2 squared plus 12 open parentheses negative 2 close plus 9, and it kicks out. It's going to give me negative 3. So that's all I was doing, was I was just using the table of values, since that way I could see a visualization of my graph to find my vertex. After my vertex, number 3 is the axis of symmetry. So for number 3, we're looking for our AOS, which is nothing more than our x portion of our vertex. So that's x equals negative 2. Number 4, oops, I'm supposed to change colors. Number 4 is going to be our x-intercept. So if we're looking for the x-intercept, we let y be equal to 0. So we go to our table, so second table, and we look for y equals 0. And now we can see that, in this one we can actually see them, because they actually occur at whole integers. So our x-intercepts occur at negative 3, 0, and at -1, 0. Our y-intercepts, so 5, looking for our y-intercepts, that means we're going to let x be equal to 0. So we go to 0 on the x, and that occurs at 0, 9. So now let's go make sense of those. Let's take a look at the graph again. So we see our vertexes at -2, -3. We see that it crosses the x-axis at -2 and at -1. And it crosses the y-axis at 0, 9. So looking good. Our last thing is to plot those things and graph them. So on the graphing calculator, which we'll take a look at in just one second, on the graphing calculator when we do these, obviously you'll plot your vertex first. So you'll go over -2, -3, so you'll plot your vertex, and then you can plot any other point. You can plot an x-intercept, you can plot your y-intercept. You just have to plot 2 points, and it draws the graph for you symmetrically. So if in our case here, we have several points we can plot, and so then that way we can get our rough sketch by hand to understand. Alright, so that's going to be graphing a quadratic function when it's in standard form. I'm going to hit pause real quickly, and we'll make sure that we feel good with how to do that inside of my math lab. Alright, so real quickly we'll take a look at this guy. If we go through this process here of step number 1, well, part 1 right here is just items for the vertex. So I didn't necessarily follow the steps. I just kind of went through this generic pattern. So to find the vertex, we say x is equal to -b over 2a. So that would be a -6 over 2 times 1. So that would be 6 over 2, which is equal to 3. So right now I'd be at 3. Remember, we can then take our graphing calculator and we can plug that guy in. So we have x squared minus 6x plus 11. We can graph it and kind of see how we're doing. Alright, so I can see I'm over 3. Looks like I'm up 2. Let's check out the table. In the table, we can see that when we go down to x equals 3, yep, sure enough, that occurs at 3, 2. So my actual vertex is 3, 2. Once I plug in that x into the original equation, I get a 2 out. Our next step on this guy, so let me go ahead and type that in. Okay, good job. So my next step is to draw the graph, so I'll click on this thing, make it big. Alright, I'm drawing a parabola, so I'm going to choose a parabola. Notice in the directions it says to plot the vertex. So at this point, I'm going to plot the vertex, which is over 3 up 2. Now at this point, I need to plot another point. Well, that's where our x-intercepts and y-intercepts come into play. I may not have asked you for the x-intercepts and y-intercepts in this problem yet, but if you did that, if you went ahead and did, that would be step 4, and you found your x-intercepts, that means you're going to let y be equal to 0. So you scroll down through this guy and you're like, okay, do I see any y's equal to 0? No, in this case I don't. Okay, that's fine. I don't see any. Obviously if I look at the graph, I can see that, well, that makes sense. It doesn't cross the x-axis, but it definitely crosses the y-axis. So I go back to my table. I know that on step 5, if I was looking for y-intercepts, that means I'm going to let x be equal to 0. And so I can see right there, I have a y-intercept at 0, 11. So 0 for x, 11 for y. So now I can come over here and I can plot this second point at 0, 11. Now I have the shape of my graph based upon my vertex and one other point. It forms the symmetry over that axis of symmetry. So I can save it and I can check it. Oops, wrong button. I can save it and I can check it. So then it moves me on to what is the axis of symmetry and walks me through. Okay, so that's kind of how you put that guy into your calculator when you're actually graphing it from standard form. Alright, so that wraps this video up. I'm going to come back and make a last video talking about domain and range real quickly and intervals of increase and decrease, which we've talked about before, but just a quick review.